This video is the first in a series where I'm trying to explain how transformer models actually work, but visually. I've seen a lot of diagrams and explanations, and honestly, none of them really clicked for me. They show boxes and arrows, but you never get a feel for the machine as a whole. So instead of starting with equations, I wanted to step back and show the entire system from 10,000 feet. Later on, we'll zoom in, slow down, and open every single box. Attention, feed-forward layers, embeddings, all of it. One big reason I'm doing this is because there's a lot of confusion around things like heads, layers, feed-forward networks, what they are, and how they actually fit together. So let's start simple. A transformer is built out of layers. Each layer takes some input and spits out a slightly improved version of that same input. Before the first layer, words are turned into numbers, vectors, using token embeddings. We also add positional information so the model knows where each word is in the sentence. Inside a single layer, two main things happen. First, attention. In this model, there are 96 attention heads running in parallel. Each one looks at the input in a slightly different way and figures out which words matter to which other words. Then comes the feed-forward network. Basically, two big matrix transformations with a nonlinearity in between. This part does most of the heavy lifting. Together, all of this takes the input vectors and turns them into new vectors that carry more information than before, about meaning, position, and context. And here's the wild part. Just one layer of this already has about 1.8 billion trainable parameters. Those are just numbers the model keeps tweaking over and over using backpropagation and massive amounts of text until the outputs start making sense. But that's only one layer. The full model stacks 96 identical layers on top of each other. And yes, that means 96 heads per layer across 96 layers for a total of 9,216 attention heads in the entire model. The goal of this whole system is actually pretty simple. Take words, turn them into vectors, and repeatedly transform those vectors until they encode what the words mean, where they appear, and how they relate to everything else in the sentence. We start with plain vectors that barely know anything. We end with vectors that are packed with context. Now, here's something that usually surprises people. When the model predicts the next word, it doesn't look at all the words again. It uses only the final vector of the last word. That one vector already contains information about the entire input, all the meanings, all the relationships, all the positions. From that single vector, the model computes probabilities over the entire vocabulary and picks the next word. Pretty crazy, right? But none of this intelligence appears by magic. During training, the process runs in reverse. After the model makes a guess, we compare it to the correct next word, measure how wrong it was, and then send that error signal backward through the entire network. Every matrix, every attention head, every one of those billions of parameters gets nudged just a tiny amount in the direction that would have made the guess better. Then we do it again and again across sentences, books, articles, code, conversations, essentially all the text we can get our hands on. Over time, those tiny nudges accumulate into structure, patterns form, meaning emerges. That's what training really is. Forward to predict, backward to correct, repeated at massive scale. And that scale, both in data and in parameters, is exactly why we call it a large language model. To wrap things up, GPT-3, the model this visualization is based on, has about 175 billion trainable parameters in total, every one of them learned from data. This video is just the overview, the map. In the next videos, we'll start zooming in and unpacking how each part actually works, one piece at a time. Thanks so much for tuning in. If you're interested in more in-depth content and more content like this, then don't forget to like and subscribe and drop any comments down below.